Hello, today Mirko and myself will be discussing facial recognition. So, firstly, we would like to discuss prosopagnosia. It is the ability to see the person in front of you but be completely unable to recognize their face. It is usually resulting from some kind of brain damage or in some cases present at birth with no brain damage visible. So this seems to imply the existence of some special neural structure involved almost exclusively in the recognition and discrimination of faces. There's also a condition called super recognizers. They're magnificently accurate in face recognition, even though they have no other special abilities. And in a study, these people are constantly able to remember faces that they viewed only briefly at some distant point in their past. But for us normal people, our ability to recognize faces differs widely. Finally, I would like to talk about the inversion effect, which is displayed in this graph. So in one study, performance in recognizing faces suffered for all of the upside-down faces. The effect was much larger for faces than for any other stimuli, as can be seen in this graph. For upright faces, the number of errors was much lower than for upright houses. But for inverted faces, the number of errors was much higher than for inverted houses. So finally, seeing upside-down faces. In this picture, you can see Margaret Thatcher with her face upside down, right here. The faces look similar to Margaret Thatcher when they're upside down, but when they're turned the right side up, then we see the horrifying difference between the first picture and the right side up first picture. And so finally, this shows the face recognition is strongly dependent on orientation in ways other forms of object recognition are not.
There are plenty of examples that show that facial recognition uses a different part of the brain compared to regular object recognition. So, a natural question is, what happens inside the brain that makes facial recognition so different to normal vision? We have seen how regular vision is based on the analysis of the single parts of an object. Face recognition is different as it doesn't depend on single parts of the face, but rather on the overall configuration of the face. This is called holistic perception, and it is also what machines use to recognize faces. Some examples of holistic features are the spacing between the eyes, distance between the nose and the mouth, or the height of the forehead relative to the width of the face. This approach also partially explains the optical illusion of the upside-down faces and the phenomenon of face pareidolia, which is when we see faces in objects. Since our brain cares only about the distances between characteristic traits and not the single parts of the faces, we have the impression to see a face even though we know what we are seeing isn't alive nor has eyes, nose or mouth. Finally, I would like to conclude with yet another optical illusion. If you look between the two images without focusing too much on the faces on the sides, you should be able to see the faces turn into monster-like creatures. This optical illusion is due to the fact that our brain sees a lot of faces, so it focuses more on the characteristic features of each face and enhances them so that we can remember them easily.